I am GP Vikishore. I am an associate professor in ECE department. This is micro in communication in digital communication engineering lab. This for 4-1. So the purpose of this lab is if you find out all the parameters whatever is there in micro and digital communication lab, you can apply this lab in telecommunications, radars and navigation. And in digital communication lab we are going to find out different experiments. So if you find out any parameters on this one, we can able to apply this one in any industries like in communications and in ISRO, DRDO and all that. You can able to get the jobs if you apply and whatever the knowledge we have on this lab, you can apply this one in practical applications.
I am P. Srikanth, Associate Professor in the Department of ECE, and this is a basic simulation lab. And this lab is used in the second year first semester for ECE students. In this laboratory, the students are going to simulate the programs in the MATLAB, and here they learn how to generate the basic signals using MATLAB, and how to design and analyze various systems, and how to analyze various signals. And when if you go to any DRDO defense organizations like DRDO, RCI, DRDL, there they will use the various signals, and to generate such type of signals we use this MATLAB, and the students will learn how to generate and how to use them in the applications like defense organization. And please have a quick view of this laboratory.
I am R. Srinivasarao, Associate Professor, ECE Department. Digital Signal Processing Lab. The object of the digital signal processor is to analyze and process the discrete time signals, and it is useful in multimedia applications, such as, for example, watching a live cricket match in a small smartphone. And in this lab, students will design and analyze the various kinds of filters, such as infinite impulse response, IR filters, and finite impulse response, that is FIR filters. Now in this experimentation, in this lab, students already they are designing FIR filter, Butterworth low pass filter with a cutoff frequency and sampling frequency 48,000 Hz, and cutoff passband edge frequency 9,600, and cutoff frequency and stop band frequency at 12,000 frequency, and the magnitude, and they are analyzing the properties magnitude and frequency response.
My name is P. Ravi Babu, working as Associate Professor in the Department of ECE, and this lab is Embedded Systems Lab, and we will have different types of experiments in this lab. We can interface different types of I/O devices, input and output devices to the processors and controllers, and we design different types of embedded systems with the use of microprocessors or microcontrollers, and using different software tools. We can have, after learning this lab, the students can able to design embedded systems on their own. After learning this, after completing their BTech, they can get good jobs in the embedded systems field. And we do different types of experiments, and we have different types of different types of equipments in this lab to design embedded systems, and these are the equipments. By using these equipments, we'll design different types of systems.
My name is B. Srinivasarao. Here I am working as Associate Professor, and I am teaching the subject microprocessor and microcontrollers. And the main purpose of this lab is to learn the different kinds of electronic equipments which are very advanced, which are using in the industry of electronics, like washing machines, our lift called as elevator, and automobile engineering. And in medical field we are using this microprocessor microcontrollers because These microprocessors, microcontrollers are very well minimized equipment to do such kind of jobs which were already designed and done by the different equipment like electromechanical. And now we have minimized the same equipment and we are using in the different applications. And here we have so many equipment in the microprocessor microcontroller lab. We can have a look, and this is called as the microprocessor kit. This microprocessor kit is having so many chips which are called as the interfacing chips like 8255 peripheral interface and ADC, DAC, ICs. And by using this kit, we can connect to the different interfacing kits, and we can connect and we can verify those outputs on the interfacing kits. And here we have the 30 systems in our laboratory, and at a time we can accommodate 33 students, and we can perform the different programs here.
Myself, Yakaya, Assistant Professor in ECE Department. I am going to dealing ECAD and VLSI lab. In this, ECAD, Electronic Computer Aided Design, and a very large scale integration. In this, we are using the Xilinx software 9.2 version. In this, so we are going to modeling the digital systems in this design. So for that purpose, we are going to writing the VHDL code, hardware description language here. So to model the digital systems, we are going to have a very high speed integrated circuit hardware description language here. So here, for example, I have taken this digital system, right? For that, I have written the code here. So depends on different syntax are there here. So to model any digital system, I'm using the VHDL code. So according to the syntaxes, then I can verify the functionality and the synthesis of this one. So means what here we can generate the RTL schematic gate level diagrams here. So for that, we can check the functionality of this one as well as all the modules in this one, right? So we can see this output of this kit, right? Outputs of this simulation as well as RTL schematics we can show in these systems like here. So simulated output is this, RTL schematic is this. Like this, we can look around of this all the systems, right? All the outputs we can generate like this. Simulation part, this is RTL schematic, this. So we can look around in these systems for the outputs.
This is Dr. Sumita Bashni, Head, Department of Electronics and Communication. This lab belongs to Analog Communications. In this Analog Communication lab, we are going to deal with different modulation and demodulation techniques, as well as the multiplexing and demultiplexing techniques. After learning this lab, students have the huge vacancies during central government organizations like DRDO, BEL, BSNL. Let's have one program like FM modulation. This modulation will give the variations of the high frequency signal in accordance with the message signal. Here we have two types of the signals, that is carrier signal as well as the message signal. In this one, carrier signal frequency varies in accordance with the amplitude of the message signal. Here you have, this is the message signal, this is your carrier signal. Message signal is have the low frequency signal, carrier is having the high frequency signal. The modulated signal is like this, because in the positive portion of the message signal, carrier signal varies, as well as the negative portion of the message signal, carrier frequencies varies. So this total will give the frequency modulation. In the portion of the demodulation, same modulated signal is converted into the message signal, that is your original signal. Now to develop that FM modulation, here you are using IC called 8038 IC. This IC is also called it as a voltage controlled oscillator or free running oscillator. So based upon this IC, we are going to generate the carrier signal, that is your high frequency signal, and input signal, that is your audio frequency signal, we treat it as a message signal giving as input. So based upon these two inputs, the entire IC will generate the three different types of the outputs based upon the 3 pins. If you are considering the output across the second pin of IC, it will give the sine wave. If you are considering the output across the third pin, it will give the square wave. If you are considering the output across the 9th pin, it will give the triangular wave. Now in this experiment, we are connecting only sine wave from the second pin. So this output is your FM output. So after learning this FM modulation, it will have the huge applications in radio, broadcasting, as well as the radar. Let's have a brief look about the different types of the experiments exist in this lab. Let's have a look.
I am Professor Ravi Kumar, Professor of ECE Department. So this lab is Pulse and Digital Circuits Lab for second year ECE students. So in this lab, students will be doing experiments like linear wave shaping, non-linear wave shaping, and different type of multivibrators. So basically these circuits are useful for the design of filters, attenuators, integrator, differentiator, and to generate different type of waveforms. So after completing the BTech course, so this knowledge is very useful for the design of, for example, filters, which are useful in the selection of particular set of frequency components.
My name is B. Giriraju, faculty in charge of ECE Lab. So ICA stands for, this is the Integrated Circuit Applications Lab. So actually I am professor of ECE department. So the mainly using for the purpose of this lab is manufacturing of ICs. So actually in the future this lab using for the purpose of study about VLSI and embedded systems. So remaining things you can observe here.
I am Rajesh, Associate Professor of ECE Department. This is VLSI Lab. In VLSI Lab, we are going to learn how to design schematic designs of digital systems and the layout design. And this layout design is used in the fab unit, where we physically fabricate integrated circuit or chips. And these chips are used in all the electronic applications. And our college has got for layout designing Cadence tools, and this is a licensed version. Where we can do one schematic design, we can test it, and we can create a layout of the technology used is 180 nanometer, and the design will support for other 90 nanometer also.
I am Professor Chandrasekhar, and this is Electronic Devices and Circuits Lab. This is a basic electronics lab used for electronics and communication students, where they learn the beginning of electronics. They learn the behavior of various components like resistors, inductors, capacitors, and then also they learn about the oscilloscope, how to operate the oscilloscope, signal generators, function generators. The knowledge they gain in this lab is very much helpful and useful to build their own circuit design and so on like. Yeah, this is Santosh, Assistant Professor of ECE Department. Here I am dealing the lab of electron circuit analysis. So whatever the subject we learn in the circuits in the class, that we verify here practically. So we have amplifier, class A power amplifier and oscillator circuits. Theoretically we studied in the class. Practically here we verify using the circuit main components of oscillator, and we have kit of class A amplifier. So directly by connecting the power supply here and input from function generator, we can check the output on CRO, and you can by using this multimeter, ammeter, you can calculate the value of current, how much current passing through this current. So by using these values, we can calculate the efficiency of class A amplifier, and these are very useful. The circuits what we are going to practically we are doing, these circuits are very much useful for after completing of your BTech project, and in mini project, for doing mini project and for doing main project also, these circuits are very much useful, and it is better for their experience of electronic circuits.